Let's take a look at a few examples of relations and try to determine domain and range, and then also figure out, is this relation that special thing called a function? Okay, so here we see mostly just lists of coordinate points. The domain values are the x values. The range values are the y values. So my x values are always first in the coordinate point, okay? And we list them as a set in this case. So it's -2, -3, and -4. Now you can write them in that order, but what we should aim to do is try to write them in ascending order. So from least to greatest, okay? So the smallest number here is -4. And then I've got -3 and -2, okay? So I list it as a set. So these curly brackets are set notation. Now, if you write them in a different order, I'm not going to mark you wrong, okay? But we want to avoid writing the same number twice if that ever happens, okay? The range values are the y values. Let's do a different color there. So y, y, and y. Those numbers are 2, 3, and 4. And that's actually the order from smallest to biggest. So I'm going to write 2, 3, and 4. Okay? So there's my domain, there's my range. The question is, does every x have only one y? So basically I want to see, do any of the x values repeat and have more than one y value? Well, -2 is only paired with 2. There's no -2 for x anywhere else. -3 is only paired with 3. There are no other points that have x as -3. And -4 is only paired with 4. So there's no other place where -4 is an x value is paired with another y value. So this, in fact, is yes, it is a function. Every x has only one y. None of the x's are duplicated and paired with more than one y. All right, let's go over and take a look at problem number 2. So the domain on problem number 2 are the x values, x, x, x. I see a 3, and a 2. So my unique numbers are 2 and 3. The 3 was used twice, but I'm not going to list it twice, okay? We do not want to duplicate numbers when we list domain and range. All right, the range values, y, y, and y, are 2, 3, and 4 again. All right, the question is this relation a function? Well, I've got x is 3 paired with both 2 and 3. So that means that one x has 2 y's. That violates the rule, so this is not a function, okay? And that's because of this point and this point. They have one x value with 2 different y values, which is a violation of that 1-to-1 rule. All right, let's take a look at problem number 3. Domain values, x, x, x are 1, 2, and 3. 1, 2, and 3. And then the range value, y, y, and y, are 2, 2, and 2. Well, there's only one y value. It was the same number 3 times, so I listed just once. We want to avoid the repetition in the set. All right, now is this a function? Now this is where things get a little confusing. I've got x is 1 is paired with 2, x is 2 is paired with 2, x is 3 is paired with 2. Now I'm using the y value multiple times, but a function is about, do I use the domain value more than once? So in this particular case, this is in fact still a function because every x has only one y value paired with it. I'm using the y value multiple times, but that's allowed in a function. It's the x value cannot be used more than once, okay? All right, so problem number 4. The x's and y's are already separated for us into a table, so now I just need to list my domain values are the x's, and they are 1, 2, 3, 4 in order from smallest to biggest. My range values are the y values over here, and they are 1, 4, 9, and 16. You may have noticed that they happen to be the perfect squares. Not significant. Here we're just identifying domain and range. We don't have to identify a rule to get from x to y. All right, the question is every x value paired with only one y value? And when I look at this part of the table, I see there's no repetition in the x values. So that means that this is yes, it is a function, okay? You'll find that many relations are in fact functions, okay? All right. That's it for this video. We'll see you in the next one for section 2.